Hi everybody, this is Mr. Bowman, and in this lesson we are going to talk more about rates of change, notation, interpretations, and then we'll finish up with some applications of that. So yesterday, or last time we met, we talked about the rate of change being the slope of a function at a specific point. We talked about the notation f prime of a being the slope of function f at the input value or x value of a. And we use that notation and that terminology in a variety of ways. F prime of a is called the derivative of f at a. We can also refer to it as the slope of the graph at, I shouldn't say at point, at A, the slope of the line tangent to the graph of f at point A, f of A. So think about it, this is your input value to the function, f of A is the output value, and f prime of A would be the slope at that point. We also call it the instantaneous rate of change of f at A. And there's a variety of notations for that. One of them is the one over here on the right-hand side, and this is useful when we want to express the derivative at a particular x value. So df, the derivative of f, with respect to x, or the rate of change with respect to x, the rate of change of f with respect to x at an input value of a. And we read this df dx evaluated at a. So let's take a look at an example of that. We're coming back to a problem we've seen before. Apple's annual, or Apple Corporation's annual net sales over an 8-year period. So let's look at some information that we have here. S of t is the function, sales over time in trillions of dollars. The input variable is time in years. So the slope of our line, or our tangent line at any point, is going to be trillions of dollars per year. The rate of change can be written as S prime. If we want to find the slope of that line at an input value of 6, S prime of 6, that slope has been found for us. They drew in the tangent line over here. I'm going to cover it in red at t equals 6. At t equals 6, the sales were actually $13.93 trillion a year, but they were, trillion dollars, but they were increasing at a rate of $4.51 trillion per year. So back to our notation over here. S prime of 6 is approximately 4.51, or another way of saying that is the derivative of s with respect to time at t equals 6 is approximately 4.51, and there should be some units on that. That should be trillion of dollars per year. The rate of change is red. The derivative of s, that should be a space there, at 6 is approximately 4.51. Again, trillion dollars per year. We should always have units associated with our derivatives. The rate of change is interpreted as, quote, at the end of the 6th fiscal year, Apple Corporation's annual net sales were increasing by approximately $4.51 trillion per year. And I want you to pause for a minute and take note of all the detail there. Okay? So they told us when, at the end of the 6th year. They told us what, Apple Corporation's annual net sales. They told us how they were increasing. They told us by how much, 4.51, and they gave us units, trillions of dollars a year. So I want to take a look at some examples of some statements about that derivative and point out some flaws with some of them and point out what should be said instead. So we'll start with this first example. The rate of change of Apple Corporation's annual net sales at the end of 6 years is $4.51 trillion per year. All right, that's a pretty good statement. The problem with that is that it's missing the following. It should say increasing at a rate of. Okay, derivatives are rates of change, so we want to point that out, and we like to do that in a way that somebody not familiar with calculus can understand that. So the rate of change of Apple's annual net sales at the end of 6 years is increasing at a rate of $4.51 trillion per year. Now we've hit all those things. We've told what it's about, what's happening to it, when it's happening, how it's changing, it's increasing, and there are units associated with it. Let's take a look at another example. This example, the slope of the line tangent to the annual net sales graph at I think there's something missing there, at t equals 6 is 4.51. So there's a few issues with this. Number one, there's no context. We don't know what this is about. It's about Apple Corporation's annual net sales. We don't know what t represents. Its time seems reasonable, but that would be an assumption that we're making at the end of 6 years. We know that the slope of the line tangent is 4.51, but that's a kind of a technical way of saying that. For somebody that's not familiar with calculus, they wouldn't know that it's the rate of change at t equals 6 years, or at the end of 6 years. And there's also no units associated with that. So there's all kinds of things missing there. Let's take a look at one more of these. Annual net sales increased by $4.51 trillion a year after 6 years. Again, it's a good statement, but it's not telling us any context here. It also there's a bit of a problem when it says increased. It should say is increasing by. And the idea here is that saying increased or decreased is basically saying over some period of time, and that's not what a derivative is. A derivative is at this moment what is happening to the rate of change. So when you're interpreting derivatives, be specific when, what, how, and by how much. And by how much, we want to make sure that we include units as well. So what I'd like you to do right now is I'd like you to pause the video and answer this practice question here, and then play the video and see how you did. All right, let's see how you did. So specifics, when, at, oh, sorry. Let's go back to part A. The slope, this could depend on your tangent line. The one I drew had a slope of about 2.3 degrees Celsius per kilometer. And I figured that out by taking the point at k equal 45, t of k equal negative 30, and then drawing a tangent line, extending it out, and picking another point on that. And I picked the point 35, negative 53. So there's a positive slope there. That's something you should pay attention to. Like, make sure that your answer has the same sign as the slope of the tangent that you drew. So the derivative notation, the derivative of t with respect to k at k equal 45 is approximately 2.3 degrees Celsius per kilometer. And again, degrees Celsius per kilometer comes from the units of y divided by the units of x. And then our interpretation. When at 45 kilometers, where, I guess, above sea level, the temperature of the atmosphere, that's the what, in the polar night region is increasing, that's what it's doing, at 2.3 degrees Celsius per kilometer. All right, this next problem is a bit different. In this one, I would like you to read all the information here and be careful when you're reading this. So, for example, C of 0 is 124, but C prime of 0 is 0. Read all that information, and there's a bit of information that got pushed onto the next page as well. And try and come up with a graph of the C of H function. I'm going to pause the video, give you a chance to do that, and then you can play and check your answer. All right, so we're going to go through the solution to this together. C of 0 is equal to 124. So I'm going to estimate that to be about right there. C prime of 0 is 0. So the derivative, the slope of the tangent line at h equals 0 is 0, horizontal. C of 4 is equal to 252, so I'm going to estimate that to be about right there. And C prime of 4 is positive 48 nanograms per liter per hour. So the units of C of H divided by the units of H. And I'm going to estimate that. That is a positive slope, and I'm just going to say that it's something like that. So we got our first 4 bullet items taken care of. The concentration after 24 hours is 35.9 nanograms per milliliter, higher than it was when the dose was administered at h equals 0. So 35, so what were we? 124 plus 35, that's going to give us 159, I believe. And so we're going to be, I don't know, somewhere about right there. And we've got that bullet item taken care of. And the next bullet item is the concentration of the drug is increasing most rapidly after 4 hours. So it's increasing, and it's most rapidly after 4 hours. So 4 hours, our slope that we already drew in there for our tangent line is going to be the steepest positive slope. The maximum concentration of 380 nanograms per milliliter occurs after 8 hours. So I'm going to pick a maximum, and I'm not going to pick a maximum. It tells me it's 380, so we're going to plot that point there. And another thing I'd want to note here is that when you reach a maximum, your rate of change, or at that maximum, your rate of change should be 0, because you're going from a maximum, and I would assume that it's going to start to decrease in a moment. And then the last bullet item, between h equal 8 and h equal 24 hours, the concentration declines at a constant rate, declines at a constant rate of 14 nanograms per milliliter. In other words, the derivative there is negative. And since we know where it ends up, we can basically say, oh yeah, we're going to draw in a bunch of tangent lines that have the same slope. So literally, we have our curve roughed out for us. And I apologize, that disappeared on me, so let me pull that back, draw this in, and that is my curve. Sorry for the shaky hand here, but that's about what our curve should look like. All right, that's it for this lesson. Try the homework problems.